Hello everyone, I am Saqib Mudassir from RV College of Engineering. My topic for technical seminar is liquid assisted laser processing. As we all know, liquids play a vital role in manufacturing process. They facilitate in removal of particles and unnecessary dirt from the surfaces. They also act as a coolant for removal of heat from the heat affected zones. They also act as a lubricant for ease of movement of workpiece, thus increasing the production and the number of products in the manufacturing unit. Cleaning. It becomes an important factor as it may lead to the impurities in the final product. The dirt present on the surfaces gets into the material and results in the improper grain structures. These liquids help in the removing and the cleaning of the surfaces by reducing the cohesive forces present between the surfaces of the workpiece and the dirt. The liquids are beneficial at removing the radioactive contaminants in the nuclear facilities. They are also helpful in removing the optical surfaces present in the space systems. Thus, cleaning becomes an important task. Laser shock processing. It is the process of impinging the laser light of the high intensity into the metal. The mechanical recoil impulse of the vapor and the plasma is utilized for making permanent changes in the workpiece. As the impulsive forces effect is predominant than the heating of the material. In this shock processing, the residual tensile stresses are converted into the compressive stresses. These compressive stresses results in improvement of the fatigue strength and corrosive resistance in the material. Subtractive manufacturing process. It is a non-contact process and is carried out at atmospheric pressure. It is dealt with the liquid jet laser beam machining. To increase the precision in this machining, the water jet guided laser beam machining is used. Various subtractive machining are drilling, slotting, dicing, cutting, etc. The main principle of this subtractive machining is used in the laser soldering, cleaning, etc. And subtractive machining is removing the material from the hole, so thus helping in completion of the laser ablation. Generation and modification of the particles. As shock processing and subtractive machining of laser is completed, this leads to the completion of laser ablation process as the particles are formed at the surfaces of liquid in of solids in liquids. When ablation is done in solids, the solid target gets vaporized to produce small particles. But when the same ablation is done in liquids, the particles are formed as a suspension in the liquid. Deposition of thin film, welding and cladding. In welding and cladding, the dissimilar metals are joined and fastened together. This can also be achieved by extrusion of the two dies. The dissimilar metals can be joined for formation of heat affected zone. For cladding of metal sheets, explosive welding can be used. This also has a high cooling rate which forms the fine micrograin structures. This helps in increasing the greater bonding between the two dissimilar metals. Liquids and their properties. Many liquid solvents are used for laser processing technologies. Water as a solvent can be used, followed by alcohol. Some of the metals, such as halogens, and some of the molten salts like sodium nitrate, potassium nitrate, can also be used for as a liquids in laser processing technologies. So, by saying this, I conclude my presentation. Thank you.